I'm Vincent, and welcome back to my channel. This is the third networking project on my list. Please enjoy as we follow. So let's start now, please. As a part of your NDA networking project, you are required to design and implement VIC modern hotel network. The hotel has 3 floors. In the first floor, there are 3 departments: reception, store, and logistics. In the second floor, there are 3 departments: finance, HR, and sales/marketing, while the third floor hosts the IT and admin department. Therefore, the following are part of the consideration during the design and implementation. There should be 3 routers connecting each floor, all placed in the server room in IT department. Okay, this is a very simple project, so please I don't want to waste much of our time. Let's start now. As we proceed, we are told to use 3 routers, 1 on each floor. So I'll be using 2911 router. So this is our first floor. Let's put our second floor here. This is our second floor. Let's put our second floor here, and let's put our third floor here. Okay, let's do it this way: first floor, second floor, third floor. So floor 1, floor 1, floor 2. Please, I'll be fast with this project because I have lots of configuration to do here. Floor 3. Okay, so let's check the considerations. There should be 3 routers connecting each floor, all placed in server room. Okay, all routers should be connected to each other using serial DC cable. Okay, serial DC cable. Okay, so let's add the serial interface. This is the serial interface. Okay, let me switch it off first. Okay, switch it on back. Put it on back. Then the third router. Okay, let me put it off. Okay, we are all good now. We can now connect. Okay, this is serial DC, as you can see. First floor, serial 0, serial 0, serial 1, serial 1, serial 0, serial 1. So we're good to go. The network between the routers should be 10.10.10. Okay, let's add this. I have this, what's it called, project 3. So let me copy the IP. Control-C. Okay, last one is .8/30. Okay, let's put it this way. Okay, so let's configure the interface. Let's configure the interface's IP. So let's continue. Each floor is expected to have one switch placed in the respective floor. Okay, let's configure the IP first. Router number 1. So let's start our configuration. I'll be fast with this project. Oh, okay. Enable config. So this is the interface with the clock rate. Interface serial 0/0/0. This is the interface with the clock, so we have to configure the clock rate. Clock rate. Let's query 64. Let's use 64,000. 64.123. So IP address 10.10.10.10.1 255.255.255.252. So our second interface, interface serial exit interface serial 001 IP address 10 dots. It will take 10.9 10.9. Do right. So let's move to the second router. Interface serial 0/0/1/1 clock rate 64.123 64,000. IP address 10.10 dots. The first one is .5 55.255.255.252. That is /30 network. Exit interface 0/0/0 IP address 10.10.10. This is .1 and this is .2. Do right. So our third router, configure terminal interface. This is our interface with the clock. Serial 0/0/0 clock rate 64,000. IP address 10.10.10.10. This is .9 and this is .10. 10.10 255.255.252 /30 network. Exit 00. This interface serial 001 IP address 10.10.10 dots. This is dot 5, and this will take dot 6, 255.255.255.252. Do right. So we're done with the interface configuration. So let's check the next consideration. The network between the router should be, we're done with this. Each floor is expected to have one switch placed in the respective floor. Each floor is expected to have Wi-Fi network connected to laptops and phones. Each department is expected to have a printer. Each department is expected to be in different VLAN with the following details. I made a mistake here with the following details. So let's do that. I'll be making use of my 2960 switch. So we need a switch here. Let's place it here. I need a switch here. We need a switch here. Let's place it here. Let's place it here. And we need a switch here. Let's place it here. Okay. So let's connect them. And I need a PC here, a PC here, and a PC here. Okay. Wait. Okay, let's connect the. Okay, in the first floor, let's take a look at the first floor. First floor, reception VLAN 80, store VLAN 70, and logistics VLAN 60. So we need a PC for reception, VLAN 80, VLAN 60, and VLAN 60, VLAN 80, 70, 60, VLAN 50, 40, and 30, VLAN 20, and VLAN 10. Okay, so a printer, we need a printer in each floor. Let's add a printer here, printer here, printer here, and a printer here. Wireless network, we need a wireless network. We need a wireless network. Where is this wireless network? Okay, wireless device, access point. Okay, access point here, and one access point here. So let's put it here, let's put this here, and let's put this here. So this here. So let's design our topologies. Please, I will have to pause this video so that I won't take much of our time, please. Welcome back. I'm done with the topology, and the next thing is to is cabling. So let's do the cabling. Okay. That's for VLAN 80, and this for VLAN 70, and this is VLAN 60. This is VLAN 50, and this is VLAN 40, and this is VLAN 30, this is VLAN 20, and this is VLAN 10. The VLAN 10 is our IT department. So we're done with the cabling and the topology. So the next thing is to start our configuration. So let's start from our switch. We have to start our configuration from our switch. We have to start with our VLAN configuration. So the first floor is VLAN 80. So let's read the the project. Let's go forward. So use OSPF as the routing protocol to advertise routes. So we are configuring OSPF on our routers. All devices in the network are expected to obtain IP address dynamically with their respective router configured as the DHCP server. Okay, so we are going to configure inter-VLAN routing on our router and DHCP server. All devices in the network are expected to communicate with each other. So that is inter-VLAN routing. So let's start with our VLAN configuration. So okay, enable conft. So VLAN 80. VLAN 80. VLAN 80. The name is reception. VLAN 80. Name reception. VLAN 70. Name store. And VLAN 60. Name logistics. So the next thing, so logistics. So in this is interface 0/1, 0/2, and 0/3. So interface 0/1 is a trunk port because it's carrying multiple VLANs. So interface exit. Interface fast Ethernet 0/1. Switch port more trunk. Interface fast Internet 0/2 to 3. Interface range 2 to 3. Switch port more access. Switch port access VLAN 80. VLAN 80. 4 to 5. This is 1, 2, 3, 4, 5. That's 4 to 5. Switch port more access. Switch port access VLAN 70. For this is 5, and this is fast Ethernet 6, and interface 0/6. Switch port more access. Switch port access VLAN 60. Do right. Okay, we're done with the VLAN configuration, and let's configure this gigabit 0/0. Enable conft interface gig 0/0. No shorts. So we have to configure inter-VLAN routing. We have to configure sub-interface on this port. On this port, we have to configure sub-interface so that inter-VLAN routing can be achieved. So to configure inter-VLAN routing, interface gigabit. Okay, exit. Interface gigabit 0/0 dot 80. As you can see, the our subinterface is up. So encapsulation .1q80 IP address. Let's check the requirements. Let's check the requirements. IP address for VLAN 80, as you can see, 192.168.8.1. That is our first usable address. 255.255.255.0, which is /24 network. So the next one is .70. Our address is 7.1, as you can see. 7. Okay, encapsulation .1q70. And our next is .60. Encapsulation .1q60. Then address is 6.1. That is the first usable address in the network. So we're done with the subinterface here. So copy on start, do copy. Let's use do. So we're good to go with our first floor. So our second floor. Let's start from our switch. Enable conft VLAN. This is our second floor. We're starting from VLAN 50, which is VLAN 50. So VLAN 50. Name finance. VLAN 40. Name HR. And VLAN 30. Name sales. So this is it. So this trunk fast Ethernet 0/1 is a trunk port. Interface fast Ethernet 0/1. Switchboard mode trunk. Exit interface fast Ethernet 0/. This is 2 and 3. This is 2. This is 2 and this is 3. Fast Ethernet 0/2 to 3. Interface range 2 to 3. Switchboard mode access. VLAN 50. Fast Ethernet 4 to 5. Switchboard mode access. VLAN 40. And fast Ethernet 0/6. FA 0/6. Switchboard mode access. VLAN 30. Do copy on start. Yeah, we're good to go. So let's configure our subinterface on our router. Enable conft interface gigabit 0/0, no short. So interface 0/0 dots. Let's start from VLAN 50.50. Encapsulation dot 1Q 50. IP address 192.168.5.1, 255.255.255.0. Let's check our address, our given address 5.0. So our first usable is 5.1. Good to go. .40 encapsulation .1Q40, then address 4.1. Next one is 30. Encapsulation .1Q30. Then our address is 3.1. Do right. We're done with our sub interface configuration. So the next thing is to move to our third floor. So let's move to the third floor. Let's move to third floor. So enable conft VLAN 20 name. Let's check the name for this VLAN. VLAN 20 name admin. Then VLAN 10 name, what's the name? IT. This is the IT department. IT. Okay, so fast Ethernet 0/1 is a trunk port. Interface fast Ethernet 0/1. Switch port move trunk. Exit. Interface range fast Ethernet 0/22223. Switch port access. Switch port access. VLAN 20. Then fast Ethernet 0/4 to 5. Switch port mode. Switch port mode access. Switch port access. VLAN 10. Do right. Do show VLAN brief. Okay, as you can see, 2 3 for 5. We're good to go. Okay, so let's create our some interface on our router. Fork. No domain lookup. There's a mistake there, so let's give it time to come up. So show IP interface brief. As you can see, our interfaces has been configured. As you can see, okay, why is our serial interface down? This should not be down. This should be up. Okay. Enable conft interface serial 0/0/1, no shots. Interface 0/0/0, no shot. Interface serial 0/0/0, no shot /1, no shots. Interface serial 0/0/0/0, no shots /1, no shots. So all the interfaces are up, as you can see. So let's configure our sub interface on this router. Exit, and interface gigabit 0/0, no shots. Then dot 0/0.20, because this is VLAN 20.20 encapsulation .1Q20, IP address 192.168.2.1, 255.255.255.0, .1Q10, because this is VLAN 10. As you can see, it's up. Encapsulation .1Q10. Then IP address 1.1. Do right. Do show IP interface brief. As you can see, our interfaces, they are all up. We're good. So the next thing, so let's check the next on our list. Use OSPF. Okay. All devices in the network are expected to obtain IP addresses dynamically with their respective router configured as DHCP server. So the next thing is to configure DHCP server on our routers so that our hosts can obtain IP address automatically. So let's start with that. Let's do that now. Let's start from our first floor. Exit. Let's start with service DHCP. IP DHCP pool. So the first pool is first floor reception pool. The first pool is reception. The network 192.168.8.0. Let's query. Okay, network mask 255.255.255.0. So let's query again. So our default router is 192.168.8.1, our first usable address, which is the sub-interface address. So our DNS server DNS server 192.168.8.1. Our domain name is reception.com. Okay, we're good to go. Then the next is it IP DHCP pool. Then pool, the second pool is store. Then the next thing is network is 7.0. Default router is 7.1. Then DNS server is 7.1. Then our domain name is store.com. And the third is it. Then IP DHCP pool. And the third pool is logistics. And our network is 6.0. Our default router is 6.1. DNS server 6.1. Then our domain name is logistics.com. Do right memory. Okay, so let's test our DHCP server. Desktop command line IP config. There's nothing there, so IP config /all/renew. So let's test our DHCP. As you can see, it takes 8.2. that is the second usable address in VLAN 80, as you can see. So that means our DHCP server is working, and our inter-VLAN routing is working perfectly. This is so sweet. I love networking. It's so sweet. It's so sweet. I love it. IP config /all/renew. As you can see, 6.2. Config DHCP. As you can see, 7.2. So this is our printer. Config DHCP. As you can see, 8.3. So let's configure our access points. Port 1. SSID is floor 1. Our authentication WPA2 PSK. Floor 1 at 1 to 3. So we're done with floor 1. We're done with configurations, with inter-VLAN routing, DHCP server, and VLAN configuration and IP configuration in floor 1. We're done. So we have to move to floor 2. So let's start our configuration with floor 2, which is our DHCP server configuration. So exit, okay, configure terminal, service DHCP. We have to enable the service first, then IP DHCP pool, then the pool name is, our first pool name is VLAN for VLAN 50, which is VLAN 50 is finance, then network 192.168.5.1, okay, .0, it's a network, 255.255.255.0, because it's a network. Then default router 192.168.5.1, our DNS server 192.168.5.1, then domain name is finance.com. So we're good to go. So the second DHCP server is for HR department, then default router is 4.1, then our DNS server is 4.1, and domain name is hr.com. We're good to go. Then the third server is IP DHCP pool sales, then default router is 3.1, DNS server is 3.1, then domain name is sales.com. Do right memory. As you can see, we're done with this with the second floor. So let's test our DHCP server. As you can see, it's working perfectly. As you can see, this is so sweet. I love this. This is perfect and so sweet. As you can see, okay, I have an issue with VLAN 40. So let's cross check. Let's cross check VLAN 40. Okay, VLAN 40 and VLAN 50. So let's cross check. There's something wrong with VLAN 40 and VLAN 50. Network. Okay, no network. Let's cross check. 5.1 finance. Okay, DHCP pool HR. There is no network. Same as, okay. Conf T. Let's check. IP DHCP pool HR. The network for HR is VLAN 40. 192.168.4.0, 255.255.255.0. Is that correct? 40.0? Yeah, correct. Then sales. Then for sales, exit. Okay, IP DHCP pool sales, network 192.168.3.0, 255.255.255.0. Right memory. So let's cross check again now. Let's check again. As you can see, it's working perfectly. It's working perfectly. As you can see, it's working perfectly 3.2. So let's configure our printer too. DHCP, it's working perfectly. Then our access points for wireless connection, port 0. This is floor 2. Floor 2. And floor 2 at 1, 2, 3. Okay, it's working perfectly. Then our last floor, enable conft service DHCP IP DHCP pool. Then our first pool is VLAN 20. That is third floor. VLAN 20 is admin. Our first pool is admin. Pool admin. The network 192.168.20.2.0.2.0, 192.168.2.0, then 255.255.255.0, 255.0. Default router 192.168.2.1. DNS server 192.168.2.1. DNS server 192.168.2.1. Then our domain name admin.com. Then exit. Then IPGCP pool for IT department. Then IT department. The network 192.168.1.0, 255.255.255.0. Then default router is 1.1. DNS server 1.1. Domain name is it.com. Do right. Okay, right memory. So let's test our DHCP configuration. Let's test it. Desktop, then DHCP. Let's test it. It's working. Yeah, it's working perfectly. I love this. It's working perfectly. So let's test it. Okay, let's test it. As you can see, it's taking 2.2. So let's configure our printer too. Two dot three. Yes, let's configure our access points. Floor 3. Then our password is floor 3 at 123. Perfect. So let's start to test communication within department. Okay, so let's test communication. Let's test our inter-VLAN routing. Let's test communication between our sub interfaces. So let's test communication from VLAN 10 to VLAN 20. So what's the address for VLAN 20? 2.2. Ping 192.168.2.2. It will work. It will work. As you can see, it's working. It's working perfectly. So the next thing is to configure our routing protocol on our router so that we can communicate to other routers, so that we can communicate to from first floor to second floor to third floor. So let's do that. So let's go back to our instructions. Use OSPF as the routing protocol to advertise routes. Okay, so let's start from floor 1. Okay, let's test communication within the department, within our first floor. So 192.168.8.2. Let's test communication to 8.2. Ping 192.168.8.2. It will ping. There's connection because I've configured everything correctly. Everything is correct. As you can see, there's connection. So let's ping to PC3 7.2. There is communication within the departments and between the departments. Ping 7.2. As you can see, it will ping. As you can see, it's pinging. Okay, so let's test communication from first floor to second floor. Let's just check. It won't ping, it won't go, but let's check. 5.2. Let's test communication to 5.2, which is PC1. 5.2. It won't go. See, as you can see, it won't go. So let's configure our routing protocol, which is OSPF. So use OSPF as the routing protocol. All devices in the network are expected to obtain IP addresses dynamically. We are done with that. All devices in the network are expected to communicate with each other. Okay, so let's do that now. Let's configure our routing protocol, which is OSPF. Enable conft router OSPF, our router number, our OSPF ID 100. Let's use 100. Then router ID. This is first floor 1. So let's use 1.1.1.1 as the router ID. Then let's start with our network. We have to advertise 5 networks here. This is network 1, network 2, network 3, network 4, and network 5. So let's check the networks. Do show IP interface brief. So these are networks we have to advertise. They are all up. So let's start from 192.168.6.1. So network 192.168.6.1. then let's query. So OSPF wildcard bits, that is the inverse, that is the reverse of network of network mask. So 0.0.0.255. okay, area, you have to specify the area 0. It's good. So the next is this network 7.1 area 0. Hit enter. The next is 8.1 area 0. Hit enter. And the next is 10.10.10.1 slash, this is slash 30 network. So network 10.10.10 oh, I made a mistake. I made a big mistake here. This should be 7.0. I specified IP address and non-network, so I have to reconfigure all these networks. So I will do that later. So .0, the network here is .0, which is slash 30 0.0.0.3. that is wildcard mask. So that is a wildcard mask. So dot is on .3 area 0. okay, hit enter. Then the next one is the second one is .8, which is this network .8. hit enter. So let's remove this one. I have to remove this one. 6.1. I have to remove this one. 6.1 and add no to it. Then let's do it again. 6.0. hit enter. Then 7.1 no. 7.0. hit enter. Then 8.1. then 8. Then no, let's add no. Then 8.0 and hit enter. Do right. So let's check our configuration. Show IP protocol. So let's add do. As you can see, 10.10.10.0, which is this network, and 10.10.10.8, which is this network. 192.168.6.0, 7.0, 8.0, and our router ID is 1.1.1.1. routing protocol SPF 100. So we're good to go. This is cool. So let's move to the next router. Enable conf t. Let's do show IP protocol. We shouldn't have anything here. So router OSPF 100, router ID. This is our second floor, so let's use 2.2.2.2. then let's specify our network. So the first network is let's start from this 0 0.0.0.3 area 0. Then the second one is 10.10.10. As you can see, it's already loading the neighbor. It's already forming neighbor. They are forming neighbor. It has formed neighbor with floor 1 with router 1. So area 0. Our second network, which is 10.10.10.4. So then let's specify the networks here. The network 192.168.5.0, which is the network here for VLAN 50. 5.0 or 0.0.0.255 area 0. Enter. Then the second network is 4.0 areas. Then the next one is 3.0. So do right. Show IP protocol. As you can see, our router ID is there. Our networks has been specified. 10.10.10.0. As you can see, 10.10.10.4, which is this network, and all the other networks in our floor, in second floor. So we can see that here they are all there. So as you can see, it's already forming neighbor with the first floor. So let's finish the OSPF configuration. So let's go to router 3, which is the third floor. So enable. So let's check show IP protocol. There's nothing there, so let's configure it. Conf T. So router OSPF 100. So router ID, let's use 3.3.3.3. So network, let's specify our networks. Let's start from this 10.4. 10.10.10.4 0.0.0.3 area 0. So 10. So the second network is 10.10.10.8. So the next, as you can see, it's already forming neighbor. So the next networks, so as you can see, it's already forming neighbor. Then network 192.168.20.2.0 0.0.0.255 area 0. And the next one is 1.0. Then write memory. Show IP protocol. We are good so far. We're almost done, as you can see. So let's test our IP protocol. So let's ping from floor 1 to floor 3. So let's do that now. So floor 3 is 1.2. So let's ping from floor 1 to floor 3. Let's check communication between the floors. Ping 192.168.1.2. As you can see, it's going very fast. That's so cool. That's good. So let's go to the next question. So we're done with the 8. Use OSPF as we're done with that. All devices in the network are expected to obtain we're done with that. All the devices in the network are expected to communicate with each other. So all the devices can communicate with each other now. So the next one is configure SSH in all the routers for remote logging. Okay, so we have to configure SSH on all the 3 routers. So let's do that now. Let's start now. Okay, exit. So let's start with hostname, conft hostname R1, this router 1, then username floor 1, then password floor 1 at 123. IP. Okay, let's after that IP domain name, domain name floor 1. For the domain name, let's use floor 1.com, floor1.com. Then the next is crypto key generate, RSA. Then 2048, let's use 2048. As you can see, IP SSH version 2 is more secure than version 1. Version 2. Then line VTY. Now line VTY, let's query 0 to 15. Transport input SSH, login local. So we're good with that. So we're done with that. Exit. Write memory to save the configuration. So let's go to our next router. Enable conft hostname floor 2, username floor 2, and password floor 2 at 123. IP domain name floor2.com. Then crypto key generate RSA. Crypto key generates RSA. Yes, that is 2048. Okay, as you can see, line VTY 0 to 15, login local, then transport input SSH, exit IP SSH version 2. Do right. We're done with that, so let's move to our third floor. Conft hostname, R3. Sorry, I need to check something here. Let me change the host name here. Host name R2. Do right. Host name R3. Then username floor3 and password floor3 at 123, or IP domain name floor3.com, IP SSH version 2, crypto key, generate RSA, RSA 2048, IP SSH version 2, then line VTY 0 to 15, login local, transport input SSH, do right, show run. Okay, we are almost done. So far so good. Thanks for following. As you can see, our SSH has been configured for remote login. So so let's go back to our considerations. So in IT, so configure SSH, we're done with this for remote login. In IT department, add PC called test PC to port FA0/1 and use it to test remote login. Okay, this is FA0/1. We have to add a PC to this port, so we have to change this port on our switch. In IT department, add PC called test PC to port FA0/1 and use it to test remote login. Configure port security to IT department switch to allow only test PC to access port FA0/1. Use sticky method to obtain MAC address with violation mode of shutdown. This is so simple. I love it. Okay, so let's go back to our switch. Okay, we have to add another PC called test PC. Test PC. Okay, so we have to add this test PC to to IT department for remote login. So IT department is VLAN 10, is in VLAN 10, and this is VLAN 10. So F is this port FA0/1. So we have to delete that port. Okay. So click 0/0. Then to here, let's use fast Ethernet 0/24. Then here, fast Ethernet 0/1 to our test PC. So let's configure this F0/24 as a trunk port. It's a trunk port. Enable conft interface fast Ethernet 0/24. Switch port mode trunk, then interface 0/1, switch port mode access, switch port access, VLAN 10, do right. So we're good to go. So let's check it. Configure port security to IT department switch to allow only test PC to access port fast Ethernet 0/1. Okay. So let's check our MAC address for this test PC. So this is the MAC address A8CC. So we can also check it from our command line interface, IP config /or. As you can see, this is it, A8CC. As you can see, physical address. So let's go back to our switch. So fast Ethernet 0/1, 0/1, port security. Okay, let me query. Okay, switch ports. Let's query. Switch port security. Switch port security. Let's query again. Port security violation mode. Let's query again. Shut down. Okay. Then so switch ports, ports, port security, MAC address, sticky, then MAC address, then let's put the MAC address there, paste, do right. So we're done with our port security, which is sticky. So let's test our SSH connection from our test PC. So let's log in remotely to our floor 1 router. Let's go to command line interface. So let's test our SSH remote login. Let's test our SSH. So to log in remotely, so just type SSH-L, then the the interface IP address, any of the interface IP address. You can use internal interface or external interface. So let's use the external interface, which is 10.10.10. This is 1. Let's check. Yeah, okay. Yeah, it's 10.10.10.1. So let's check. So okay, first we have to okay, which is 10.10.10.1. Invalid command. I think we have to add the what was it called? .10.10.10.1. Oh, sorry, I made a mistake here. So to remote login through SSH, then you have to add the host name here, which is floor 1, as you can see. So let's wait. Connection to timed out. Okay. Oh, sorry, I haven't configured IP address on this host. ipconfig /renew. So let's configure IP address on this device first, then let's try to log in again. As you can see, so the password is floor 1 at 123. As you can see, we are in our router, in our R1 router. So let's test connection for the R2 router, SSH, which is floor 2. Okay, 10.10.10. This is .1 and this is .2. Then .2, as you can see, floor 2 at 123. As you can see, we in. As you can see, exit. So let's test for floor 3. Then floor 3, 10. This is 10.5. This is 10.6. 10.6. As you can see, floor 3 at 123. As you can see, we in. So thanks for your time. Thanks for watching. See you another day.